I'll share my slide. So just you tell me whether you are able to see it. So just I'll refresh it for 5 minutes. So at the end of the class, you have to take one test. Quiz. Before that, I'll explain because and one more help is somebody has to do it for me. That is one of the students is not picking up our phone. So I'll give his number. At the end of the class, I'll give you the phone number. You can call him, and again, it is your responsibility. Okay. I don't know why he's joined and now he's a little bit reluctant to attend the classes. The reason is not known. So just to find it out, what is the reason behind it? Just to make a call and tell that the classes are quite okay, and whatever you are feeling, you have to convey to him and ask him to join because he's not picking up the phone. Also, maybe if you try from your side, he may pick up and explain about the classes, how it's being conducted. Then he may be interested in joining. I'll give you that in the end of the class. I'll give you his name and the phone number. Jagan, can you do it?
Okay, ma'am.
Oh, okay. So today, just you tell me whether you are able to see the slide there. You're able to see
Yes,
the
ma'am.
slide? Yeah. Okay. Oh, okay. Last class, what we have dealt is the stiffness method of analysis. That is the first unit, and we have seen something about the continuous beam, and especially we have talked about the support. That is what are the different types of support. The first one is the fixed support, then one is the roller support, and another one is the hinged support or simply supported. So that is these are the three types of supports we have seen, and the specialty of this specialty or nature of this fixed support is it won't allow any rotation. It won't allow any rotation, and it won't allow any translation also. I will. Translation and rotations are not allowed. What about this portion? This also translation is not allowed. The vertical translation, but translation means vertical direction because it is roller. Vertical translation is not allowed, but rotation is allowed. This but also if we take vertical translation is not allowed, but rotation is allowed. Here it's a fixed support. The vertical translation, that is the support can't move in the vertical direction as well as it can't rotate also. So you should not forget, because this is the basic thing in carrying out your problem in continuous beam. That is the rotation is not allowed. Rotation is prevented. The other word for prevented is restrained. Opposite of restrained is free. So free means it is allowed. It is allowed to rotate. But you take your finger. You take your finger. The end of the finger you can deflect it. It's like a hinge support. That is a pinned support. It is like a pinned support. You can move it in the vertical direction, but you can't rotate it. Your finger. That is like this is that is the nature of the pinned support. So it is a fixed support means the totally the vertical translation and rotation is prevented. Roller support means vertical translation is prevented, but rotation is allowed. It can rotate. It can rotate. So this continuous beam is having two fixed supports and two roller support, and is having a load of concentrated load at the middle and uniformly distributed load at the end. So these are things that yesterday we have seen. And one more thing is how to number it. That is, this particular beam is having three members, 1, 2, and 3. And then next step is, first thing is you have to number the member. That is, it is numbered as 1, 2, and 3. And after numbering it, you have to make a node numbering. That is, first beam is connected with the nodes 1 and 2. The second beam is connected with the node numbering 2 and 3. Third member is connected with node 3 and 4. So each node has, you have to concentrate on the each node, how many translations, how many rotations are there. That is, this particular node, if you take, it is a fixed support. So no translation, no rotation. Then this particular the support, if you are node, you talk about, you take this particular node is not having any translation. That is, it is prevented from translating. It can't move. Sorry, it can't move vertically upward or downward, but it can rotate. So this 4 is, it is not restrained. It is free. So each node has, I have numbered as the node 1, it is having a translation 1, rotation 2. Node 2, it is having a translation number 3 and rotation 4. And node 3, it is having a translation number 5 and 6. 5 and 6. And node 4 is having a translation number 7 and 8. So when you look at this one, continuous beam, you may have time to do your during the examination, because I don't know whether it's online or offline. Anyway, the difficult part of this subject is you won't find time to complete it. So you have to remember now, if you look at these numbering, 1, 3, 5 and 7 are for the translation, vertical translation. Am I correct? The odd numbering is for the translation and the even number is for the rotation. That way you have to keep it in your mind, because this odd number will go off, because something is restrained means you need not take into consideration while you are doing the calculation. But these things here, if you look at, this is restrained, of course, because of this is fixed, but this is allowed to rotate. So 4 and 6 are the degrees of, you might have learned the word degrees of freedom. Degrees of freedom, the opposite of freedom is restrained. That is, your parents may tell you should not go there. That is mean that you should not go there means that is restraining you, or they are preventing you from going to some place. That is called restraining. But is what is free? If your father and mother tell you can go to that place, means it is free. So like that, this structure is also having some restrictions because of the external supports. So the what does the external support say? This support is saying this is, you can't move in the vertical direction, but you can rotate. But this fixed support is saying you can't move it in the vertical direction as well as in the rotate also. So this is like a stringent parent. This is something like a flexible parent. So something is allowed, something is restrained. So why I am repeating is, usually the students used to commit a mistake when they are doing the problem. That is the restrained and the degree of freedom. They will if they commit any mistake, then end of the problem, all the problem, the whole of the problem will be coming in. You have to end up with the error. So you have to be very careful in calculating, in identifying the nature of support. So as I told, one more clue I given, the odd numbering is for the vertical translation and the even number is for the rotation. In this one, I say this particular beam is having a freedom of rotation at 2 places. Degree of freedom is 2. Degree of freedom is 2. What are the degrees of freedom? It can rotate at the joint 2. It can rotate at the joint 3. Kalerisi, are you agreeing with me? This particular beam is having only 2 degrees of freedom. Am I correct? Am I correct?
Yes, ma'am.
Kritika, how many degrees of freedom this particular beam is having?
2, ma'am.
Huh?
2, ma'am.
2, 2. What are the degrees of freedom? Can you tell me? What are the degrees of freedom? What are, what are the degrees of freedom?
I will attend the class one.
Kritika, yesterday you were there, no?
Yes, ma'am.
Yeah, that's what I'm asking. This particular beam has got 2 degrees of freedom. What are the degrees of freedom? Degree of freedom means it is free. So what are the degrees of freedom? this joint 2 can rotate. Am I correct?
Yes, ma'am.
This joint 3 can rotate. If you are not able to understand, I will explain with one more diagram. Wait a minute. Wait a minute. Wait a minute. I thought you may be familiar with all these words, rotation and translation. Wait a minute. Are you able to see what I'm talking about? Rotation, translation.
Yes, ma'am.
This diagram, yeah. If you take this fixed support, it is not rotating at the end. Am I correct? It is not translating at the end also. Vertical translation is not allowed. But when you look at the middle, there is some rotation. So that is why fixed. That's a very best example. Yesterday I was talking about is what I was telling. I was talking about the scale. The scale just you can hold with your finger, or you can hold with your hand. So if you are holding the entire scale with your hand, then it is giving some fixity. Just you are keeping on the top of your finger means it is giving a simple supporter. So what you have to keep in your mind is, have you noted it in yesterday's class? Otherwise, you note it down. Note it down. Draw a fixed support. Draw a fixed support and note it down. Fixed support. Vertical translation is vertical translation is restrained and
Yes, ma'am. I
rotated.
noted, ma'am.
Noted.
Yeah.
Noted. This you should not forget at any time, at any cost. You should not forget. That is, vertical translation is restrained and rotation is restrained for the fixed beam. Vertical rotation is restrained, and because throughout this analysis you have to remember this one: fixed support, vertical translation is restrained and rotation is restrained. Are you able to see? There is no rotation and there is no translation. The translation means vertical deflection. Vertical deflection is not there, but in the case of the other end is also fixed. There is no vertical translation and there is no rotation. You are able to see the color of the blue
Yes,
line, no?
yes, ma'am.
Yeah, that indicates whether it is rotating. But if you are taking the simply supported, it will rotate. That is, if you in the case of simply supported, just I'll draw and show you. Insert shapes. So suppose if it is a simply support, you take this as a simply supporter, then this is the pattern of deflection. Let us take this as a simply supported. Are you able to see the difference? Suppose this end is simply supported. So there is a rotation. Am I correct? Are you able to see the line?
Yes,
What I
ma'am.
have drawn newly. Yeah, there is a rotation at the end. Rotation means there is a slope. There is a slope. Dy by dx is there. But in the previous case, there is no rotation. Am I correct? But what about the deflection at the end? That is a simply supported. You take this as a simply supported, and if you take this as a simply supported, or should I draw and show again? That is insert shapes, because you have to be thorough with this. This is a beam. you are having a this is a simply supported beam. Other end also will have a simply supported like that. So this particular beam, what will happen? What will happen to this beam? Uh, are you able to see the difference? I'll just cancel this one. Oh, this is for the simply supporter, but for the fixed, you know the difference. But for the fixed support, there is no vertical translation. It is not moving in the vertical direction. That is, it's not getting deflected in the vertical direction. That is true for the simply supporter condition also. But rotation is here. That is theta is here. Theta is here. But for the fixed support, it is restrained. Have you noted down for the fixed support? That is rotation is restrained and translation is restrained. And for the simply supported, translation, vertical translation is restrained and rotation is free. It is free to go. I told an example. Now, if your father is telling to go to some place, permitting means it is free. You are free. If it is not, if he is not permitting to go somewhere, means it is restrained like that. This beam also of its condition, it is not allowed to rotate or translate, but this beam is permitted. It is flexible. It is like a flexible parent, so it is allowing it to translate vertically, but it's not allowing to rotate. That's the concept. So these two conditions, if you keep in your mind, it's enough. And the roller also same thing. Roller also the difference between the roll and the hinge. Here the horizontal movement is also not allowed. Horizontally also it can't translate, but it can. But in the case of roller support, it can horizontally move. The best example I told yesterday is the example of a what is that bridge, example of a bridge. So with that I will stop now, and today at the end of the class you have to take one exam, and for this all these questions I've asked, then how to find out the reaction and what is the unit of bending moment at the shear force, like simple questions of 5 questions I've asked, and you have to answer it. So this is a basic concept. So each first thing in your analysis of a problem is the you have to number the beam. The second step is number the node 1, 2, 3, 4. The third step is in each node what are the translations available. You have to mark it 1, 2, 3, 4. And one more thing, I have for the simplification purpose, I have given a clue. The odd numbers are 1, 3, 5, 7 are for the translation, and 2, 4, 6, 8 are the for the rotation. So this is the clue I have given to do the work little bit faster. So this is the thing I have given yesterday. I have taken one beam from that is the previous beam consists of 3 beams. This is the one beam I have taken, and the number of the beam is 1, and I have noted the vertical translation as 1 and the rotation as 2. Here it is 3 and 4, and the node numbering I have given as J and K. The previous problem I have given us 1 and 2. Here I have given us J and K. Anything you can mark it. You can use numbers or you can use alphabets. It's not a problem, but node numbering should be there. First, then I told something about the formulation of stiffness matrix. How to formulate the stiffness matrix. That is, when I am giving, I told all of you to feel that the force developed in your hand. I asked you to hold your pen with the right hand, and with the left hand you are applying a force. That is not a force, that is you are making the pen to move by 1 centimeter. So what was happening when you are trying to move it, you are able to feel the force in the other hand. Similarly, I am trying to, when I am giving a force unit displacement at this end, this end also will be subjected to some of the forces. What are the forces it will be subjected to? It will be subjected to the shear force and the bending moment. On the right hand also it will be subjected to a shear force and the bending moment. Similarly, when I am applying a unit rotation, the beam to rotate by unit radians, that is 1 radian. If I'm unit of rotation is radians, and if I'm trying to rotate it by 1 radians, then also this beam will be subjected to forces. So what are the forces developed? at the end A, that is at the end A, the first node, it is having a shear force of 6 EI by L and the rotation of 4 EI by L. Other end is 2 EI by L and it is what is that, 6 EI by L square. So we can prove it, but this basic concepts you have studied in BTech level itself, just is a refreshing thing just to note it down. So I think you might not have noted it yesterday. So can you note it down? Can you note? Can you draw this diagram and mark it? So this is very important. So you have to remember this number. So when you finished it, you tell me. Just you tell me that you're finished. 1 minute. 1 minute.
Mom.
You're finished. Please tell.
Mom.
You finished drawing. Just you tell me. Have you finished? Hello? Svetak, have you finished?
Yes, ma'am.
What about Kritika?
Ma'am, last one.
Ah, okay, I'll wait.
Finished, ma'am.
Finished. Second one, what about Kalaris? Finished?
Finished.
Okay. Now I'll move on to the other end. I'm giving a unit displacement at the right end and unit rotation at the right end. So the previous diagram I've given unit displacement at the left and unit rotation at the right. Here I'm giving unit displacement at the right and the unit rotation at the right end. And what will happen to the forces? Just copy this also. If you have finished, please tell me. Finished. I can move to the next slide.
Yes, ma'am.
Okay. So if I put that member stiffness matrix, that is whatever you have noted there, the numbering was, can you just note it down? That is the previous one is 1, 2, 3, 4. Similarly, this one is also 1, 2, 3, 4. So when you compile it together, you will get a matrix like this. That is 1, 2, 3, and 4. Can you note it down? The stiffness, but this the thing is you have to keep in your mind. Keep this matrix. You can just refer and you can do it, but if it's an offline exam then you have to remember this values. So it's easy to remember also. That is, first thing is 12 EI by L cube. Second one is the bending 6 EI, sorry, this is the shear and bending is 6 EI by L square. So when with along with 6 it will get L square. Then the opposite is minus 12 EI by L cube, then 6 EI by L square. Then the next row you will have this the 6a by L square and 4a by L minus 6a by L square 2a by L. So if you remember this one, then this will be the repetition of this one. That is whatever you are having, the sign convention alone will differ. That is this 12a by L cube, 6a by L square, 6a by L square, 4a by L. So this will be repeated here. This will be repeated here. The same thing only, but here you, if you see, you will have instead of 4a by L, you will have 2a by L here also. So this will be coming here, and this left hand side will be coming to this lowermost bottom. So can you then sign convention some way you have to remember. That is the here we will not have any sign negative values, but in this case this 3 you will have negative. Here the horizontal line you have negative, and here the other thing, the vertical line, you will have a negative. Some way you have to keep in your memory if it's a online offline exam. Okay, do copy it down. So I can move to the next slide now. So I have applying a u dash displacement. That is, previously I have given a unit displacement. That is 1 unit displacement. If I am applying u dash displacement, that is maybe 2 centimeter or 3 centimeter at y dash, that is along this direction. At j, what is happening to the other ends? That is, if I am apply a displacement at 1, that is u dash instead of 1, that is previously I have applied a unit displacement. And how did I note it? That is, when I am applying a unit displacement, the forces I am noting as q11 q q11 q21 and q31 q41. That is, I am applying a unit displacement of u1 at joint j, but because of that, what are the forces? Q11. So Q21. The numbering is, first you have to number the known number, that the force number. Force numbering is 1, 2, 3, 4. Shall I repeat once more? The force numbering is, the vertical translation how will you number 1, then rotation you will number 2, then the vertical translation you will number 3, and rotation you will number 4. So the force is developed because of the unit rotation. How will you do it? Q1, first you will write the node numbering. Q1, the force where you are applying at the joint 1. So it is 1. Then this is Q2, the force where you are applying 1. So I am writing 1. Then this is the force, the node is 3, where I am applying the displacement 1, node 1, node 1. So I am writing 1. Suppose if I am applying the unit displacement at this end, can you tell me the numbering? I am applying unit displacement at this end. What is the unit displacement? U3. 3 I am applying. Am I correct? 3 I am applying. In vertical displacement, U3 I am applying. So what will be the force numbering? Q1 3, Q2 3, Q3 3, and Q4 3. Do you agree with me? Have you understood? If anybody is not understanding, can you please tell me? This is a basic concept. I am the first I have to write the node numbering. What is the node? Node is the, and that node, what are the forces acting? The vertical force and the moment. That is the translation and the rotation. Translation I call it as 1. Rotation I call it as 2. At the other end, the translation, vertical translation I call it as 3, and the rotation I call it as 4. But depending upon the force where I'm applying, the displacement or the rotation I'm applying, I have to put the second numbering, because each thing force has got 2 numbering. Am I correct? Q11, Q21, Q31, and Q41. So 2 numberings are there. So first number represents the node, and the second number represents the place where you are applying the displacement or the rotation. So here I have applied the displacement at the node 1. So it is Q11, Q21, Q31, Q41. So suppose if I am applying U3 here, can you tell me the number? Or Jagan, can you tell me the numbering? I am applying a U3 here. So can you tell me the forces here? Q?
Q13,
Then
Q23,
Q23,
Q33,
3, Q 4,
43.
3. Very good, very good, very good. I wanted to know that is whether you have understood. Next question is, I have applied a unit rotation here. That is, what is that? What I have applied? U2 I have applied. Colors, can you tell me? U2 I have applied. U2 I have applied. That is the rotation. Unit rotation I applied. So can you, what are the forces? How will you call it? Can you tell me? Colors, 2 I have applied. So
Q12,
1, 2,
Q22,
uh,
Q32,
okay.
Q42.
Very good, very good. I understood. I'm happy that you have understood, because if you understand the concept, then will be easy for you to proceed further. The forces are equal to Q11 is equal to, initially when we are applying the this unit displacement, this is equal to 1. Now the stiffness is, it depends upon the, you have studied no equilibrium equation, that is external load is equal to Ku. You have studied in static analysis. The external force is equal to Ku, K into U. So similarly, you can write this. That is, if I am applying unit displacement, then we call it as U1 dash, U1, that is K11 into U1 dash, K21 into U1 dash, K31 into U1 dash, like that you can write it. Can you just copy down this diagram? This also. Applying a unit force, 1 minute. Can you draw this diagram?
Move to the next line, ma'am.
Yeah. So copy this also. With that, we will close it today and you have to take a small quiz. This quiz I won't consider for your internal exam. This is just tell you that this is the way we used to conduct the quiz. So with that, today I'll finish it off, then we'll move on to the quiz. You finished? The process I written here itself. Finished now? Finished?
Yes, ma'am.
Now note down the questions for you. Share the screen. Just you tell me whether you are able to see that slide share question. Take down the questions. Are you able to see the question? Wait, wait.
Yes, ma'am.
Yeah, take down the questions. These are simple questions. You can have a 10 minutes time is there. Take down the questions. So this is the way we used to ask the questions. So today after doing this, complete this one, you can evaluate yourself. I'll tell you the answer. You can evaluate yourself. For the next class onwards, you have to take the test in the Google form. The last question, the fifth one, you have to choose the correct one. Sorry, wait a minute. You can start doing. I'll give you 5 minutes, then we will discuss the answer. If you're finished, please tell me. We'll discuss the answer. Have you noted the question? Can you tell me the answer for the first question? You're finished? How many? Any one of you finished? Jagan, you are finished?
One question remaining.
Okay, do it. Answer for the first question. Jagan, what's the answer for the first question?
Ma'am, unit of bending moment,
Ah,
kilonewton per meter.
not per meter, kilonewton meter. Load into distance. No.
Okay, ma'am.
Load into
Kilonewton
distance.
meter.
Kilonewton meter. What is the unit of shear force?
Kilonewton.
Kilonewton. Second question, Kritika. What's the answer for the second question?
Ma'am, R equal to 6 kilonewton.
Eh?
R equal to 6 kilonewton.
What's the question? Find the reaction. How much RA is?
6 kilonewton, ma'am.
6 or 3? Sweda, what is your answer?
R is equal to 6, ma'am.
What is the distance 2 meter from A? That is 10 into 3. No, 10 into 3. Okay, okay. Okay, 6 only. That's the correct answer. That's the correct answer. Then third question. Colors, what is the third question? It's true or false? Colors,
Yes, ma'am.
it is true or false?
But false, ma'am.
False. Why? The order should be what? Then what is the correct order?
Analysis.
Then design. Am I correct?
Yes, ma'am.
First planning, the analysis, then design. What's the answer for fourth one? Who will answer, Sweta?
125 kilonewton
Okay.
meter, ma'am.
Fifth question. Again, what is correct? First one or second one?
First one, ma'am.
First one. Okay. So this is the preliminary some like information I want to share with you, and this is a way I'll be asking the question, and subsequent classes the question will be posted in Google Forms, and you have to do it in the class itself. Okay. So not in the extra time, in the class itself we can do it.